we are going to start with chemical equilibrium. So, how do we define chemical equilibrium? Chemical equilibrium. Alright. So, in this one, concentrations of all reactants and products. So, it is the state where the concentrations of all reactants and products remain constant with time. And on the molecular level, there is frantic activity. So equilibrium is not a static, it's a dynamic. It is not static, but is highly dynamic situation. So that's about chemical equilibrium. So we can again further define that equilibrium, how this equilibrium looks like. So you can see equilibrium is microscopically static and microscopically dynamic. So let's take an example. Let's say we have N2 gas and 3 moles of H2 gas. They are in equilibrium. You can see the forward arrow and backward arrow. It gives 2 moles of ammonia gas and H3 gas. And when we write changes in concentration, so let's see when we plot the graph, let's say we have concentration and we have a time. Okay. So what happened? I'm going to draw for H2 different color. Let's say H2 different colors, 3 moles. So we start from here. Initially it has about 3 moles. It starts reacting, and it becomes static. Alright, constant. Now for N2 gas, it starts with 1 mole. So it's N2 gas. Alright. So those reactors starts with a higher concentration and then it's going to react and then it becomes constant. Now we take NH3 concentration. Let's see, I'm going to change color. NH3 concentrate. Initially NH3 is 0, then it starts forming, and since it is 2 moles between H2 and N2, and that's NH3. Now you can see at one point equilibrium established in that reaction. So how do we define in that case? I'm going to write perfect definition of chemical equilibrium. Okay, so what is that? Rate. Alright, so I'm going to write definition for that. Concentrations reach levels where the rate of the forward reaction equals the rate of reverse reaction. That's where chemical equilibrium establishes. I'm going to write that one here. Let's see. Equilibrium established during that time. So when we see, I'm going to plot the graph again. So let's say if we have reaction rates and time, reaction rates and time, okay, and when you see forward rate, so forward rate, let's say start from here and it establish, and then reverse rate when it starts with 0 and it's established equilibrium. Alright, so when you see here at one point, after that equilibrium established, okay, that's equilibrium. So what is this line tell us? It tells us forward rate equals reverse rate. So that's the concentration level where the forward and reverse reaction establish. Forward rate and reverse rate should be equal.